In this video, we'll look at question 15 from the second paper of the 2017 exam. So in this question, we have two different progressions. In terms of notation, they're actually written more like functions, because we have this f of something equals, but we can just think of this as the first element of the progression equals 5. In any case, to define these progressions, we have the first terms and then recursive formulas, which, however, are separate for when the term is odd and when it's even. And our task is to find this difference of the 1000th term of the first progression and the 1000th term of the second progression. So let's look at the first progression and see what its first terms look like. So the first term, we are told, is 5, and because this is odd, we then need to use our first formula and multiply 5 by 3 and add 1, which gives us 16. And now that is even, so we get to use the second formula for a change, and that is much simpler. We just divide by 2. So we get 8, and 8 again is even, so we again divide by 2. We get 4, and we again divide by 2 because that's again even, and 2 is even 2. So we get to do that once again, and the sixth term will be just 1. Well, we can't see an emerging pattern yet, so let's just carry on. 1 is an odd number, so the first formula comes into play again, so 3 times 1 plus 1 is 4. Then we divide by 2 because that's even. We divide by 2 because that's again even. And 1 times 3 plus 1 is 4, 2, 1, 4, 2, 1, 4, 2, 1, and so on. So it looks like this first progression goes all around the number line up and down, but then it settles down on a small group of numbers, just on 4, 2, and 1, and it loops around through these three numbers, around and around and around. So it's 4th, 7th, 10th, and then 13th, 16th element, and so on, will all be 4s. In other words, numbers which give a remainder 1 after they are divided by 3. So say if we have 10, divided by 3 is 3, and remainder 1, that means the value of the function or the progression there will be 4. And that is indeed the case for 1000, because 1000 divided by 3 is just 3, 3, 3, and remainder 1. So this value will be 4. So let's write it down here and look at G now. So let's get started. We have G of 1 is 3, which is an odd number, and according to this recipe, we need to add 5 to it. And 3 plus 5 is 8. Then that's an even number, so we just divide by 2. 8 divided by 2 is 4. Again, even, we use the second formula. That gives us 2, 1. And now that's odd, not even, so we use the first formula again. We add 5 to get 6. And 6 divided by 2 as an even number gives us 3. 3 plus 5 is 8. That's an even number, so we divide by 2 according to this formula. 4, 2, 1, 6, 3, 8, 4, 2, 1, 6, and so on. So once again, we found a loop, except this time the period of the loop is 6. So we get the same result every 6 numbers. So say every number that gives a remainder 4 after it's divided by 6 will have the value 2 in G. For example, here, the G of 10 is 2 because 10 divided by 6 gives you remainder 4. And since 1000 divided by 6 is in fact 166, and the remainder will be 4, it is guaranteed by our inspection that that term of the progression will be 2. So G of 1000 is 2. And hence, this difference, f of 1000 minus g of 1000, is 4 minus 2, which equals 2. And that was the correct final answer, and in the exam it was under option D.